Hello everyone, good morning.
Good morning.
Okay, so today we have session for the remaining revision portion which was left in the previous session by Professor Ushan. Till then, how is the preparation for the anthem?
Going good, sir.
Going answer.
So we will start with week 11 first. Okay, so by now I think you all are aware of what is a random variable, right? And you are also able to distinguish between discrete random variable and continuous random variable, right?
Yes, sir.
Okay, so today we will discuss one of the discrete random variable, which is named as Bernoulli random variable. Okay, so suppose I am doing an experiment. Any experiment is performed, and it has only, so I can classify it into two outcomes. One is my success, another is failure, right? Then if I associate a random variable to it, let's say x, such that if I get success, it takes the value 1. If I get failure, it takes the value 0. Okay? And let's say probability of success be p. So for failure, it would be 1 minus p. Such kind of random variable is called Bernoulli random variable. Any doubt till now?
Also,
So let's take an example. Right? Suppose I'm doing an experiment of tossing a coin. So my outcomes are either head or tails, right? And let's say I'm saying my success is to get an head. And if I get tail, it's a failure. So if I associate a random variable x, which counts the number of successes I am getting, you can say number of success or head I am getting. So it should get an increment of 1 if heads appear, right? And 0 if tails appear. Right. So in such experiment, I can classify my outcomes into two categories, success and failure, such that it takes the value 1 if I get the success and 0 otherwise. And let's say probability of getting heads is p, and for tails it's 1 minus p. Then I can say that x follows Bernoulli with parameter p. Okay. Now we can also extend it, right? Suppose instead of tossing coin only once, I am tossing the coin n times. And I'm tossing the same coin n times. So if I'm tossing the same coin n times, it means each toss is independent of each other. and probability of getting heads is constant for each toss. Because suppose initially probability of getting heads is 0.4. So in the first toss it would be 0.4, in the second toss it would be 0.4, and so on till the nth toss it would be 0.4 only for getting heads, right?
Yes, sir.
Now let's say I define a random variable x1. X1 is let's say number of heads in the first toss, right? So number of heads in the first toss, it means it should get an increment of 1 if heads, 0 otherwise, right? Or if tails. Similarly, I can define another random variable x2. X2 is number of heads in second toss only. So x2 is again a Bernoulli random variable, which will take value 1 if I get head, which is my success, and 0 if I get tails, right? Similarly, I can define x3, x4, and so on up to xn. Xn will be number of heads in the nth toss. So again, xn will take the value 1 if heads appear in the nth toss and 0 if tails, right? If you notice carefully, here my x1 follows Bernoulli with parameter p if probability of getting head is, let's say, p, which is constant for each toss. Similarly, x2 also follows Bernoulli. Similarly, x3, x4, and so on up to xn follows Bernoulli. Now suppose I define another random variable x. X is number of heads in n tosses of a coin. So I can simply write x as the sum of all these x1, x2, xn. Number of heads in the first toss, in the second toss, so on up to nth toss. If I add them all, I will get the total number of heads in the n tosses of a coin, right?
Yes, sir.
And so here, if you notice, x is nothing but binomial n comma p, because I am doing the n tosses with probability of success p. So in other words, I can say binomial is nothing but the sum of n independent and identical Bernoulli random variables Is this thing clear?
Yes, sir.
Okay. So Bernoulli is in general is nothing but, you can say, a binomial random variable with number n equals 1, you can say, right? And if you do it multiple times independently, and by identical I mean that this probability of it is constant throughout each trial or each toss of a coin, right? So now you can link Bernoulli with the binomial. Okay, now let's look at the expectation part. Okay, let's start with Bernoulli. Suppose x1 follows Bernoulli with p, right? So x1 can take value 1 if I get success and 0 if we get failure. Probability of getting a success is p, and for failure it's 1 minus p. You can easily compute the expectation of it, right? It is nothing but 1 times p plus 0 times 1 minus p, right? Simply p. Now remember, for binomial, we said it is nothing but sum of n independent Bernoulli random variables, right? And for each of the xi here, I goes from 1 to n, follows Bernoulli with parameter p. So by using the property of expectation, I can write it as expectation of x1 plus expectation of x2. If you recall the week 10 properties of expectation, and it would be nothing but p plus p plus p n times p, right? This is the expectation for binomial random variable. Any doubt till now?
Sir.
Yes. Okay, let's similarly for the variance thing, you can, if x follows Bernoulli with parameter p, x, it takes the value 0 and 1, simply 1 with probability p, 0 with probability 1 minus p. Again, you can simply compute the variance for the same, right? Using the formula. So on solving, you will simply get p times 1 minus p. Now recall, we know that binomial is nothing but sum of an independent and an identical Bernoulli random variables, right? Since all of these x1, x2, x3, so on up to xn are independent, so I can write it like this using the property of variance for independent random variables, and p 1 minus p, right? That's the variance for binomial part. Okay. One more thing, you all know the PMF of binomial. It is this, right? You can also link it with this thing. Binomial is nothing but sum of n independent and identical Bernoulli trials. Okay. Suppose I want to find the probability that I get only one success. So if you look closely, I can get success in any one of these n trials if any one of my xi is equal to 1 and rest others will be 0. The sum will be 1. My x will take the value 1. So any of these one position, I can choose in NC1 base. I should get success at that position. And in the remaining n minus 1 position, I should get the failure. Similarly, for x equals 2, it means I should get 2 successes in the n trials. So I can get 2 successes at any of these n positions. So let's first choose 2 positions on which I have to get success, which can be done in NC 2 ways. Now getting success at those 2 places, it would be p squared, and getting failure at remaining n minus 2. And so on, it can be generalized like this. Any doubt in the binomial part? Anyone?
No, sir.
No, sir.
So 1 minus p के power n minus x होगा ना?
Oh yeah, n minus x.
Sir, can you please go on the previous slide?
It's whiteboard, I erase it. But you have to ask the previous slide. It's variance part.
Yes, sir.
Okay, so okay, so if it follows Bernoulli, right? All of them, x1, x2, xn. you can simply find their variance. Variance of x1 will be nothing but expectation of x squared minus expectation of x whole square, right? On solving, you will get simply p times 1 minus p. And we know that binomial is nothing but sum of n independent and identical Bernoulli random variables. Since all of these x1, x2, xn are independent, so by using the property of variance, you can write it like that. Since all of these are identical, so variance will be same for all of them. That's n times p times 1 minus p for binomial. Is it clear?
Yes, sir, I got it.
Okay. So anyone, any doubt in week 11? I think we are done with the week 11 content.
Excuse me, sir.
Yes.
If PMF given in the expression wise, how we can find out the N and the P? There is one activity question in 10.2.
10.2 or 11?
Sorry, 11.2. They given PMF. N we can find out from that expression. How we can find out P value?
11.2.
Yes, the
So-
first question. Yes. From that we can find out that the N is 5, isn't it, sir?
N is 5. Yeah. First, you have to convert the CDF into PMF, right?
Yes, sir.
Were you able to do that? Shall we do it?
Yes, sir, I can do that. Just to subtract in each and every.
Yeah. So suppose, okay, suppose you get the PMF, right? You know x takes the value 0, 1, 2, 3 up to 5, right?
Yes, sir.
For if my x follows binomial n comma p, possible values which x can take is 0, 1, 2, so on up to n. So on comparing, you can see that n equals 5 here, right?
5.
That's okay. Once you get the PMF, it means you also obtain the probability, right? So always consider the extreme ones. Either consider x equals 0 or consider x equals 5. Because what will happen is, for probability x equals 0 means 5c0 p raised to the power 0, 1 minus p raised to the power 5, right? It is nothing but 1 minus p raised to the power 5. And you know the probability as well.
Okay. So from that we can find out. Okay, sir.
Or if you take this extreme, again 5c5 is
5c5, p power 5, 1 minus p power 0. Okay.
it's nothing but p raised to the power 5. So you can directly obtain the value of p from there.
Okay, sir. Okay. Thank you.
Any other doubt in week 11 before we move further?
Sir, could you
Yeah.
go back to 11.1, sir? 11.1 assignment.
11 point.
Last question, sir. Last question.
This one?
Yes, sir. Yes, sir.
Expectation. Okay, so you know when is the variance of Bernoulli trial or binomial is maximum?
So 0.5.
0.5, right? This statement is given by man in the lecture as well, if you don't know how to find the maximum or minimum. Okay. So variance will be maximum when my p equals 0.5, right?
Yes, sir.
So here it is asking for what value of a is considered to as the most uncertain Bernoulli trial. The most uncertain means as the variance increases, there is more uncertainty. Right? Because
Okay.
variance tells you how much your values are deviating from the mean. So more it deviates, more is the uncertainty.
Okay.
So you have to find the value of A such that
Okay.
probability y equal to 1 becomes 0.5, right? So
Okay.
if I take A equals 3,
Hmm.
so probability that x less than equal to 3 is 0.5.
Okay, sir. First three events put together.
Yeah. So for 3, I will have P as 0.5. So for that value of A, it will be most uncertain Bernoulli trial.
Excuse me, could you please explain it again? I did not understand. So I know how to find the maximum value. That is by differentiating the first
Yeah.
differentiation that ma'am told about. So how will we find this with that?
So we know variance will be maximum when P is 0.5, right? And I know the PMF of X. It takes value 0.1 for X equals 1, 0.2, something like that. If I remember. This is given to you, right? And your Y is some Bernoulli trial. For variance of Y to be maximum, it should be Bernoulli 0.5, which means P equals 0.5, right? And it takes value 1 if X is less than equal to some number and 0 otherwise, right? So what does Bernoulli 0.5 means? That probability Y equal to 1 is 0.5, right?
Yes.
Probability Y equal to 1 means probability X less than equal to A is 0.5. Because it takes value 1 in this case. So if you look at X equals 3, A equals 3, it means probability X less than equal to 3. It is nothing but 0.1 plus 0.2 plus 0.2, 0.5. So I can take A as 3. In that case, my P will be 0.5 for Y.
Yes, sir. Understood.
Understood?
Yes,
Yeah,
sir.
got it. Got it, got it.
Question 11.5, question number 8.
0.5.
Last question. It's a standard deviation.
This one,
Yes, yes.
standard deviation, number of yellow balls drawn. Okay. 6 are red, 9 are yellow. Okay. In total, there are 15 balls, right?
Yes,
Out of which 6 are red and 9 are yellow, right?
yes,
And I am drawing it with replacement.
yes.
With replacement means at each draw, probability of drawing a red ball is 6 by 15
Yes,
and yellow will be 9 by 15, right?
yes,
Okay. So my random variable X is number of yellow balls drawn.
yes.
So probability of success. My success is if I draw the yellow ball. It is nothing but 9 by 15.
So here, can we use a binomial distribution for this question?
Yeah, because P is constant throughout, right? It would be 9 by 15 for each and every trial. And also you are drawing independently, like one after the other.
So this binomial we can use for with replacement questions also.
Yeah, condition should be satisfied, right? We are drawing the balls independently, one. Because once I draw the ball, right? Suppose I draw the red ball first.
This probability will change now while drawing the balls.
No, see.
And we are keeping.
Suppose I draw the red ball first, right? Its probability is 6 by 15.
Okay.
And then probability of drawing the yellow ball at second draw, it would be 9 by 15.
Okay, this is with replacement, so probability is will be constant.
Constant.
If without replacement, we cannot apply Bernoulli.
Yeah. You also need to check the independence, right?
Yes, yes.
So for independence, you can see, suppose probability of yellow at second draw, given I have drawn the red at first, it would be still 9/15.
Yes, yes.
So you see that the conditional, let's say this is my event A, this is event B. Probability A given B is probability of A. This is the condition for independence, right? Is satisfied here.
Yes, yes.
So that's independent draws we are doing. Probability is constant throughout. N is fixed. So you can use binomial, right? Okay. Anyone, anything else?
So can you just tell me what are the conditions to use binomial and Bernoulli, sir?
See, Bernoulli is nothing but when your n equals 1, it becomes Bernoulli.
Right. Okay.
Okay. So condition should be your n should be fixed. You should know that you are going to do only 10 trials, 12 trials, and all that, right?
Right.
Your p should be constant for all the trials. Like in first trial, if p equals 0.4, then in second trial it should be 0.4. For third, so on up to nth trial, it should remain 0.4. Okay. Third is your trial should be independent. It means, suppose that drawing ball, right? 6 red, 9 yellow. If I have drawn the red ball in the first draw, it is not affecting the probability of drawing yellow or red ball in the second draw, right? So trials are independent. If these three conditions are satisfied, you can use Bernoulli or binomial. Okay.
Excuse me, sir.
Yes.
Sir, we use binomial when we have independent and identical trials. So
Yeah.
do we have any distribution for dependent trials also?
For dependent trials, yeah, I think one distribution which you have studied is hypergeometric, right?
Yes, sir. So hypergeometric random variable.
Yeah. When you do something without replacement, then suppose I have drawn the red ball first, right? So now I am left with 5 red and 9 yellow. So for second draw, probability of yellow would be 9/14.
Yes, sir.
So we have done some similar kind of thing in hypergeometric, right? Like if I am doing 5 draws of the ball, what is the expected number of red balls I can get? It was nothing but mn/2, if you remember the hypergeometric thing.
So, sir, can we draw PMF MCDF for that also?
For hypergeometric,
Yes, sir.
yeah. See, yes. For one basic example for hypergeometric, suppose this is some kind of sea or something. Okay, and there are two types of fish: fish of type A and fish of type B. Okay. In total, you have to catch n fishes. You have to catch, right? And in total, there are n fishes, right? Of this n, let's say your m are of type A and n minus m are of type B. Okay.
Yes, sir.
So, see, my n fish to be caught. Okay. So my random variable is number of type A fish I have caught. Okay. So if you see, my x can take value 0, 1, so on up to m, right?
Yes, sir.
Okay. So the probability that I got, let's say generalize it to x. I got x fishes of type A. It means I should get x from these m. I can choose
Yes, sir.
any of these x fishes from these n, right? Remaining n minus x fishes, I can count from this n minus n.
Yes, sir.
So these are my favorable cases, right?
Divide
Total
by
number of
total.
possibilities, I need to catch only n out of this capital N. This is the PMF for hypergeometric. Okay. And if you go
Okay.
more deep into hypergeometric, there are some conditions as well. If m is less than n, m is greater than n, okay, these all you will study further in stats 2. Okay. But for now,
Okay, sir.
the general information is, general idea of hypergeometric is something like that. And here, if you notice, we are doing it without replacement as well.
Yes,
Because
sir.
if I catch one fish from here, I am left with only m minus 1 in the second row.
Yes, sir.
So probability keeps getting changed after each trial. So in such cases, we use hypergeometric. Okay. Anything else? Anyone?
Excuse me, sir. How did you get NCN in the bottom?
A total number of fish. I can catch any of the n fishes of this total capital N, right?
Okay, okay.
This is total and this is my favorable.
Mm. Okay.
Okay, yeah. One more thing in the previous session, it was a skewness thing, right? So there are three kinds of things. Okay. First is symmetric. Symmetric means it divides it into equal two parts, your mean something. Okay. So in symmetric, your binomial will become symmetric if your n is large. It would become symmetric irrespective of value of p. P should be just greater than 0. If your n is small and p equals 0.5, then also it will be symmetric. Okay. If n is small but p is less than 0.5, it becomes right skewed. And if p is greater than 0.5 and n is small, these all are for n is small, right? It becomes left skewed. Are you all aware of the skewness and this right skewed, left skewed thing? How the graph looks and everything?
Yes, sir.
Okay, great. I think we can move to week.
Sir, you're saying that if n is large, it becomes symmetric anyhow, right?
Yeah, it will become symmetric.
But then p must be p is always greater than 0. Okay.
Yeah, greater than 0, and it means it should not be. P could be any value, but not exact 0 or exact 1. Any in between 0 and 1.
It should not be at the extremes, neither 0 nor 1.
Yeah.
Excuse me, sir. For
Yes.
large value of n, the binomial distribution approaches symmetry, isn't it, sir? So
Yeah.
how we can fix the limit?
Fix the n value.
Is there any how to fix that n value? Try
Okay,
us.
so in statistics, if n is greater than 30, we assume it to be large. Generally.
Okay. Okay, sir. In session, ma'am told that with the example n equal to 40. So that's why I'm asking.
Yeah, it depends on situation. But even if you look at n equal to 40, it's tending to symmetric. It's, you know,
For all the
on the way.
values of probability, it approaches symmetry.
Yeah.
Okay, thank you.
Okay. And yeah, you all are aware you have having time mock today.
Yes, sir. They have received the email, sir.
I received it, right? And okay, after this time mock will be you can say similar weightage or similar pattern to the end term paper. Okay, weightage wise. As soon as time mock and you will have another practice mock, which will consist of some previous term questions, just for practice, nothing related to weightage or something. But for end term, I would suggest you to go through all the mock papers or mock for quiz 1, quiz 2, everything.
Sir, this timed mock would be from 7 to 9, but it would be of 1.5 hour duration. That means after 1.5 hours of us attempting it, it would automatically end for us.
No, it would automatically end at 9. You can set timer for yourself to do it in 1.5 hours. We are keeping that half hour extra because all of you may not be able to start exactly at 7, right? Some may
What
start
if
at
I
7.
start at 7 exactly? Then will my test end at 9 or would it end at 8:30?
At 9 for everyone.
Okay.
So today we have the mock,
Yeah, today.
but I didn't get any. Was it given in the mail, sir?
Yeah, I think you all may have just received it.
Just we received just half an hour,
half an hour back. Yeah.
Okay. Thank you.
Excuse me.
Yeah.
Yeah. What did you say about this practice mock? I could not hear
Okay,
properly.
So for time mock, we tried to give you an idea of what would be the weightage overall or something.
Yes.
So, but we also had a lot of extra questions as well. So we put it in some practice mocks.
So on similar lines, but more number of questions in practice mock.
Yeah.
Okay.
Sir,
Thank you.
after 9, it will be available now?
Yeah, after 9, both these will be available.
Okay, sir.
And regarding more distribution on weightage, week 1 to 4, it would be 25%. 5 to 8, 25%. 9, 10, 25, and 11 to 25. Okay. This will be the weightage, approximately. Shall we proceed to week 12 now?
Yes, sir.
Yes, sir.
Okay. So week 12, it is consists of continuous random variable. By now, here are only 2 distributions covered, which is uniform and exponential. When you go into stats 2, you will cover a lot of more such distributions. Yeah. So we said that, okay, firstly, you all are aware of what is continuous. You are able to distinguish between continuous and discrete random variables, right? Till now.
Yes, sir.
Yes, sir.
So we say, if we say that x follows uniform in some interval a comma b, what it means is, so that this is some graph, this is value a, this is value b, this is some, let's say, something like this. That's your plot for the uniform distribution. So what happens in continuous random variable is, we suppose I need the value of probability in this range. So we compute the area under the curve for this region only. Right? So in continuous random variable, we always find area in some intervals only. If someone asks what is the exact, let's say, what is the probability at exactly this point, right? So if you look closely, exactly this point would be something, let's say it's here. this axis over here. So exactly at this point, if you find the area of this line, so area of line is 0, right? Approximately. It would be very small, close to very 0. So that's why whenever someone asks the exact value of probability at a fixed point, it is always 0. So whenever we come into continuous random variable, we talk about some having chances of being lying in this region. So PMF for uniform random variable, it is 1 over b minus a if your x belongs to interval a comma b and 0 otherwise. Any doubt?
No, sir.
Okay. Next thing comes is the CDF. CDF.
Sir, this is PDF of uniform distribution, right?
Yeah, this is PDF. Yeah. So yeah, for discrete random variable we use the word PMF, but here in continuous we use the word PDF. It is because if you look at the PMF, right? Let's say Bernoulli. Let's look at it. It gives me the exact value, that it would be P, it would be 1 minus P. I know the exact value of probability, right? But in continuous random variable, we find the areas, we try to find the density under this region and under this curve. That's why it's somewhat referred to as probability density function and not probability mass function. Probability mass function means it gives you the exact value at that point. While density function, it gives you the how dense it is, how much area it covers under this. Okay. So CDF for uniform, it is x minus a over b minus a. X belongs to interval a comma b. X, I think, greater than a. And but less than b. And as soon as it touches the b, it will reach the 1. And 0 if it is less than. These things one can obtain by using the integration formula or by using area under the curve. Integration part, I think you all have done in maths 1 by now. So you all can try to do that, but mostly integration will be used in the stats 2. In stats 1, you can work out with these formulas as well. Any doubt in it?
So here 1 will be greater than b, no? X greater than b.
Yeah, greater than b.
Okay.
So similarly, for if x follows exponential, okay, before that, if x follows uniform a comma b, then your expected value of uniform is nothing but a plus b by 2, right? And variance of x is b minus a whole square by 12. So what happens over how to find this? So here expectation of x is nothing but we integrate over the complete region a to b x times the PDF, which is 1 over b minus a. So those who know integration, for stats and we assume that you guys are not aware of integration. Those who knew the integration part can solve and check.
Sir, only 1 by b minus a dx, no, sir? After integrating, it will be x.
Yeah. It would be x square by 2.
Sir,
if you know
for expectation or variance?
for expectation. For variance, you need to use this formula. Expected value of x square minus. So once you find expectation of x, you also have to find the expectation of x square. which is nothing but integration of x square times the PDF. Right? Any doubt in it? Anyone?
No, sir.
And moving to the exponential part, exponential, suppose a random variable follows exponential with parameter lambda, then its PDF is given by your x should always be greater than 0, greater than or equal to 0, you can say, or greater than 0 will also be fine. Your PDF, it means that it takes the value less than something. It simply means you're integrating 0 to x times this PDF. And solving, we get this. Okay? You can directly remember the formula if you are not aware of the integration. Okay? Similarly, expect mean of exponential distribution is again integrating over the whole range of x times the PDF. And on solving, one gets it is 1 over lambda. And similarly, variance of x is nothing but 1 over lambda squared. Is it clear or any doubt in it?
Sir, here f of x, what does it represent? Like dx is expectation variance and f of
It
x
is
is not.
PDF. The capital F is CDF.
Okay, thank you.
Similarly, expectation is nothing but mean, and it is variance, right? Any doubt in week 12?
Yeah, actually, in which cases P of x less than or equal to x is equals to less than x? In uniform distribution and exponential, less than or equals to is equals to less than, right?
Okay. So whenever we have continuous random variable, okay, so probability of, let's say, this thing, let's say random variable x, you have x lies between a and b, or let's say it's less than or equal to a, this, but we have equal to over here, or we have equal to at both this. All will be same for continuous random variable. It is because if you look at this equal to part, right, we know at any point it is 0. So I can simply
Yes.
eliminate it, right? But if you come to discrete, it will be all different.
Yes, then we'll get equals to.
In discrete, it matters whether there is symbol of equal to or not, right?
Okay. I have one doubt in practice assignment 12.
This is
First question. Actually, I solved it with integration, but in the solution, it given the point at x equal to 2, f of x equal to 2k in the solution part.
and the value of k, right?
With integration, I solved this, but I'm not getting why that is given in the solution, how it got. Can you click on the check answers? We'll get solution, right? It's given at x equal to 2, f of x equal to 2k. How we got it?
Okay. equation of the line is kx, right? Kx and k
How
minus
this
x plus 4.
equation of line, he says it's f of x, right? F of x means it's the value at a y-axis, I think. It's not?
Yeah. It's something like this, right?
Yes. The
This is-
value at the peak will be k of x.
And this is your point something. It is 0.2.
This is what I'm unable to understand. In the question, it says f of x equals to kx in between 0 to 2.
Yeah, it between 0, it means the equation of this line.
But normally
Yes.
f of x we are taking on the y-axis as a value 0, 1, 2, 3, 4, right?
That's for PMF. This is PDF. In PDF, it is the equation. Okay, see,
Okay, okay. Yes, yes.
in between 0 and 2, right?
Yes.
And then this thing. So if you look at the exactly at 0.2, this is the equation of line, right? Kx. So exactly at 0.2, it means my x equals 2. So it would be 2k. Or if you want to compute from this line, equation of this line is this k minus x plus 4. So
But in PDF, we don't talk about exactly at 2, right?
exactly
We'll
at
talk
2.
about
We are not
less
talking
than
about probability. It's something you can say geometry thing, right?
Okay.
The graph thing we studied in maths 1. I am finding the point. This point will be, I know my x is 2. Value of y is 2k. So this point is 2, 2k, right?
I'm not getting how this 2k came. You're keeping just in place of x2 in y equal to kx.
Suppose this is my line, right? Line of
Yes.
equation y equal to ax plus b.
Yes, yes.
If I know x equals 2, then
Okay,
y
fine.
would be 2a plus b, right?
Yes, yes, understood.
Equation of this line is kx. If I
Yes,
put
yes.
x equal to, this point will be 2k.
2x. Okay, 2k.
2, 2k, right?
Okay, fine.
So I know that this point is 2k. It means that the height of my triangle is 2k.
Yes, yes, I understood.
Is 4.
I can do. Yeah. Thank you.
Anything else? No.
Sir, how to calculate expectation and variance for triangular distribution?
Expectation and variance for triangular distribution.
Yes, sir.
I don't think you will be given such question. Is there any question like that?
No, sir, but actually ma'am didn't tell in the lecture, so I thought how to calculate that.
Yeah, that involves integration thing. Okay. And we assume that you guys are not aware of integration. All that you will study in stats 2.
Okay, sir.
Once you guys, so yeah, that's why I try to work on integration and log thing in maths 1 properly. Only then you will be able to pass stats 2 easily. Because it involves a lot of integration, lot of that.
Excuse me.
Yes.
Yeah, there is a different mock scheduled for 30th March, right?
30th March? No,
Yeah.
that for stats 1 it's 2.
It is showing in the calendar that on 30th March from 7 to 9 p.m. there is a scheduled mock. So that is going to be on today.
7? No, that's session, mock session. Session to discuss the mock test.
Acha, okay. The questions of this mocks, questions will be discussed on that day.
Yes.
Okay.
It's a
Thank
mock
you.
session.
Okay, thanks.
Anyone, anything else?
सर जो प्रैक्टिस सेशन का जो solving वाला जो है, is that being uploaded into the website or
practice assignment solutions?
Practice assignments. The solutions have been uploaded, right? Or it is not? Because
whenever you click on check answer, you will see this feedback as the solution in the feedback for every question. Whenever you click on check answer, you will see your feedbacks.
I have one question, but it's not from our GA, it's from some previous question. Can you help?
Yeah.
Can I read it? If a fair coin is tossed 20 times, then what is the probability of obtaining more heads than tails? That is the question.
The probability of more heads than tail, right?
Yes. More heads than tails. Coin is tossed 20 times.
Tossing the coin 20 times, right? Okay. So let's say my random variable x is number of heads, okay? And if you see, x can take value 0, 1, 2, so on up to 20, right?
Yes.
I need to find that number of heads is greater than number of tails, okay? So see, if number of heads is 0, number of tails will be 20, 19, 18, 0, right? So in general, I should get at least 11 heads. In that case, only number of heads would be greater than number of tails.
Yes.
Because if I get 10 heads, I will have 10 tails.
Yes, true.
So to get more heads than number of tail, I should have at least 11 heads.
Okay.
And then you can just binomial simply, right?
Sir, this will entail a lot of calculation, isn't it?
It was an MCQ question. Options were given. Just have to
Here
simply
the correct option is 1/2 minus 20 C10 1/2 whole power 21.
1/2 minus
20 C10 1/2 whole power 21. This is the correct answer.
Correct answer, yeah. There was more than one option correct or only one? More than one, right?
One more option also there. This is sum of 1 minus sum of I equal to 0 to 10, 20 Ci 1/2 whole power 20.
Yeah, this one is simple, right? 1 minus getting less than 11 heads.
But it's 20, 1/2 power 20 times. Okay, getting only heads.
Yeah, P is 0.5, right? 1/2. So 1 minus P is also 1/2.
Yes.
So that's why it is 20.
So this second answer is telling we are getting only heads.
Second answer, it is we are getting less than 11 heads, right? 1 minus, I get less than 11 heads.
Less than 11. Okay.
I need at least 11 heads. If I subtract the cases where I'm getting less than 11 heads, I will get the probability of getting at least 11, right?
Okay.
Sir, I don't understand the first choice. How is that?
First choice, yeah, you have to work on that.
Sorry, I didn't understand.
So this will be very long, sir. Like 10 times we have to do this whole process, 10 or 11 times.
Which no, that this is an okay. Previous. Okay, so the question was something like this. fair coin is tossed 20 times. What is the probability of obtaining more heads than tails?
Same question.
Yeah, more than one options can be correct. See, more heads than tails means I should get at least 11 heads, right? Okay. Over there.
This is practice 11 assignment. This question 12.
It is previous term quiz 4.
Okay.
See, so I'm tossing the coin 20 times, right? My n equals 20. Let random variable x be the number of heads. Condition is I should obtain more heads than tails, right? So see, if I obtain 0 heads, it means I got 20 tails, right? My condition is not satisfied. Similarly, if I got 1 head, I will have 19 tails. Again, this condition is not satisfied. Similarly, if I have 10 heads, I will have 10 tails. Again, this condition won't be satisfied, right? But as soon as I have 11 heads, I will have only 9 tails. So this condition will be satisfied for all the values of x greater than or equal to 11. Is this thing clear?
Yes.
Yes, sir.
So probability that x takes the value greater than or equal to 11, I can write it as 1 minus probability x less than or equal to 10.
Yes.
So it is nothing but I goes from 0 to 10, 20 ci, p raised to the power I 1 minus p raised to the power 20 minus I, right?
Yes.
I will add all from 0, so on, so forth up to 10, right? If you notice one keyword here, it is a fair coin. Fair coin means p equals 0.5, which means 1 minus p is also equals 0.5. So I can write it as 0 to 10, 20 ci, 0.5 I can write 1 by 2 raised to the power I, 1 by 2 raised to the power 20 minus I. So it is nothing but this thing, right?
Yes, yes, this option is okay. The B
Such
option
as-
is only, yeah, this is easy.
Yes.
Sir, for this, then if it is an unbiased coin or biased coin, in
Value
such
of p will change.
so which one will change, sir?
Only value of p will change, right? That
P
we plug.
probability, like will it be a 0.5 always, or it will be different?
It is 0.5 because it is mentioned and it is a fair coin, right? If it is has been not a fair coin, some probability of getting heads would be given to me, right?
So that probability will be given in the mentioned in the question.
Yeah.
Sir, what about B, sir? B requires actual calculation.
Okay, yeah. For B thing, you will
Is
have
there any other way to find?
Sir, if this was to power 20, it was making sense. This one is 21 is not making sense.
21. Okay, it is because we have we have taken the half. If you take half common, right? It would be 1 minus 20 C10, 1 by 2 raised to the power 20. Now it makes sense a bit.
Yes, understood.
Yes, yes, this is okay.
Half times 1 minus probability x equals 10,
Yes,
right?
yes.
So, okay, so why we are doing it? Let's see. In general, your x can take value 0, 1, 2, so forth up
20.
to 9, 10, 11, and then up to 20, right?
Yes.
So if you remember, see, it is my fair coin. Fair coin means p equals 0.5, right? it means my graph would be symmetric in some sense.
Yes, yes.
This point would be my something x equals 10, right?
Yes.
So this area and this area should be equal, right?
Yes.
It means x taking the value 0 to 9 is same as x taking the value
11 to 20.
11 to 20, right?
Yes.
This is all the same. Let's take it x, and let's use another sum. Let's say probability it takes value 0 to 9, it's a. So 11 to 20, it will also be a because symmetry, right? So in general, it is 2a plus probability that it takes value x equals 10 is 1. So 2a equals,
This much thinking is difficult.
so a is nothing but half upon 1 minus probability x equals 10. That's option B. If you
So
take half instead.
these questions are in the portal where we
No,
find.
someone shared in the WhatsApp, in Telegram and WhatsApp, someone shared it's a previous paper.
Okay, in Telegram group where.
Unofficial.
Okay.
I think all of you have all the previous year by now. I think there is some group.
Yeah, someone is sharing. So actually,
Yeah.
I want to see how the question paper is. So yesterday I solved it. This one on the stats.
Okay, so the previous term it was, I think 90% was from week 9 to 12.
Yes, you told. Yeah, you told.
This time the weightage is 25%, like that.
Yes, you told me. Just I want to see how the pattern will come from week 11, 10, 11 and 12. Just I check this. Could you help me to solve question number the top 36? Yeah, one uniform distribution question is there. It's
this one.
Yes. I struck here how it's 5 by 8.
You will see it in the mock. Then we'll discuss.
Same.
Yeah, in mock we use the previous question.
So this will come as mock today.
Yeah.
Okay, then we'll discuss later.
So
Thank
can you just see question from activity 9.5? I have a little doubt in one question.
Yeah, sure. Activity 9.5, right?
Yes, please. Question number 3.
Question number 3. Okay. How did you approach this one?
So in this question, in the beginning, it is said that it is a fair coin.
Unfair.
So it is an unfair coin.
Hmm.
Yeah, so it is asking that how do we find the probability of an unfair coin? I know for a fair coin, it is a half of getting a head or a tail.
Yeah, for unfair, you need this histogram is given, right? This PMF.
Yes.
So for using PMF, you have to find. Okay, let's see. You have to find. It will show head, right? And the PMF given in use of number of tails.
Yes.
So let's write the PMF. Let's your x be the number of tails. Okay? In 3 tosses, it can take value either 0, 1, 2, or 3, right?
Yes.
Probabilities, it is given in the graph 0.027, 0.189, and so on, right?
Mm-hmm.
So let's only focus on the extreme ones. Okay, let's ignore these ones. X equal to 0. Okay. So if you notice your x, it is nothing but binomial. Or if you don't
it's
want to
taking.
look at, okay, let's not, for week 9, let's not go to binomial. I'm getting 0 tails. 0 tails means I'm getting 3 heads.
Yes.
In 3 tosses, I'm getting 3 heads. It means this is the thing I am getting.
Yes.
Probability would be P times P times P.
Mm.
P cube equals 0.027. 0.3, right? For heads.
Okay.
Similarly, if you like now you know binomial, you can use binomial as well, right? Binomial, I'm doing 3 tosses, probability of success P, but this P is for tails, right? Because you are getting probability of tails over here.
Yes.
So probability x equal to 0 is 3c0, p raised to the power 0, 1 minus p raised to the power 3. It is 0.027. So 1 minus p, which is tails, which is heads here, right? P is tails, so 1 minus p is for heads. Good point. Is it clear?
Yeah, it is clear. Because when I was doing, I did not read binomial then. So I
Yeah,
thought
without
it's easy to
binomial,
do that.
you can use. Yeah, when you get to know about binomial, I think previous weeks also become easier.
Yes, yes. I think that's correct. Okay. Thank you.
Anyone, anything else? Or shall we close Kapila?
Sir, any important tips, sir?
It's like think then it's uniformly distributed for all the weeks. If you are aware of concept, you'll be able to do it. Calculation part, calculation part might be a one thing. Yeah. Do the calculations a bit smartly, right? Suppose if I am getting something, don't try to reduce the fraction so early. If suppose I'm getting something 1/4 minus, let's say, 2/6, something then division thing, right? Something. It's 4.
Difficulty levels, sir?
It would be simple. Okay, suppose I'm getting something like this, right? Don't try to directly go to the calculator. Just work a bit smartly. If you see that LCM over here is 12, right?
Yeah.
4 minus 3/12 under root 1/12. So 1/12 divided by under root 1/12. It is nothing but under root 1/12. Now, if you use the calculator, it will save time rather than using calculator over here.
Yeah.
So try to work on calculations a bit smartly. Then it won't be that difficult.
So difficulty level?
In between quiz 1 and quiz 3. Quiz 1 and quiz 2.
Yeah, okay, sir. Thank you, sir.
Sir, is there any EMQ question like this too?
Can you repeat?
So EMQ question.
EMQ question won't be here this time.
Excuse me, sir. Can you share one of the questions, like the one which the lady asked, sir? Like, I don't know where she's got it from. Previous year's questions, perhaps.
Okay,
that you don't have.
Yeah.
Yeah, this one. Like, I don't know where this is from. Can you let me find this?
This is previous term and term paper.
Okay. But we don't have access to that, right?
Yeah, we don't have it. But it's, I think a lot of your seniors are sharing. So everyone, I think, now have it.
Okay. Oh, but where, sir? Like, I don't know where to find it. Can you help me?
You can ask them if they are finding some unofficial Telegram, WhatsApp group.
Oh, okay.
Every time it gets shared. That's why we don't release solution for the same.
I see. Thank you, sir.
Sir, are we limited to week 11 and 12 only, or can I ask from week 9?
You can ask from any. We have time.
Could you please look at practice assignment 9, question number 6?
Question number 6. Okay, it would be same for This one, right?
Yes, sir.
Okay, so how did you approach this one? Well, let's see. We are playing content 10 book numbered 1 to 10. Okay.
Yes.
The right, which is okay, which is what is the probability will be knocked out at the end of this. Yeah, there is something. Your initial score is 0, maximum 5 chances. Last digit of the right. Okay, last digit of the right side page will be added to your current score, right? And if you get 0, you are out. You won't play. Okay.
So you'll be out if you get a 10, I think.
Yeah. See. So numbered 1 to 10. So the possibilities are either you can score 2, 4, 6, 8, and out. These are the only 5 possibilities, right?
Yes.
So if look at the case, you have maximum of 5 chances, right?
Yes.
So case 1 would be you get out in first chance.
Yes.
So there is only one way to get 0.
Yes.
Okay. Case 2 would be out in second chance. So in the first chance, you could get any of these 4.
Yes.
And in second chance, you must get out, which can happen only in one way. Right?
Okay.
Similarly, case 3 is out in third chance. You should get any of these 4. Yeah, 4
into
times.
4. 1.
Similarly, case 4 will be out in fourth chance.
4 cubed. Yeah, 4 cubed.
4.
4 to power
Right?
4.
So total ways to play an inning is sum of all this.
Okay.
Right?
Yes.
Which is I think 1365.
Okay.
And now the question is, what is the probability that Ramesh will be knocked out at the end of his chances, right?
Yes.
Out in fourth chance, out in fifth. Yeah, there will be one more case. He remains knocked out after 5, right?
Yes.
4 is above 5. So your probability that he will remain knocked out is favorable cases divided by total number of cases, right? Is this clear?
Yes. Sir, and question 3 of the same one.
Question 3, it will be different for everyone. You have to tell me the statements.
So, just 1 second. You can do it from whatever you have. I'll work on that.
No, it would be different.
Oh, okay, okay. Just a second. Then I haven't noted. I'm not even sure if it will open for me the same one.
Do you
It's okay.
remember the statement?
No, sir. I'm so sorry. I didn't realize that in stats it changes every time. I'll note down the question for the next.
Okay, you can post on this question forum or discourse.
Yes, sir. Thank you. I didn't realize that it changes.
Anyone, anything else?
Sir, I have a doubt.
Yeah.
So shall I, sir, actually it's from quiz 2 question. I didn't get that.
Quiz 2 question. This term, right?
Yes, sir.
Okay, which one?
Sir, I posted the question in chat box. I think last before the question, sir.
This one, right?
Yes, sir. Sir, here we are taking the 4,001 to 9,999. Is it right, sir?
Yeah.
The numbers between 4,000. So 4,001 or 4,000, sir? First starting case. 4,001. So we are not able to fill the zero in last position, right, sir?
You can. In general, you need to have only 4-digit number, right?
Yes, sir. In first position, we can fill 4, 5, or 6 in 3 ways, right, sir?
Right. After that, you are left with only 5 digits.
Yes, sir.
Any of the 5 can come here, any of the 4 and any of the 3, right?
But in last case, we cannot fill 0, right, sir? Because it is 4,001 to 9.
Okay, see, suppose I fill 4 here, right?
Yes, sir.
And I fill 0 here.
Sir, 4,001. How can it take 0, sir? 4,001, 2, 3, 4,
No,
5.
remaining 2 digits I have to fill. Right? Suppose I am fixing 4 at first and 0 here, right? And take any of these. Let's say 2 and 3.
Okay,
it's
sir.
still greater than 4,000.
Okay, sir. Got it.
Doesn't matter to be 0. If digit can be repeated, then that will be different case.
Okay, sir. Thanks, sir. Got it.
Anyone, anything else?
Sir, question from week 12 guided assignment.
Week 12, okay. Yeah, which one?
Question 5, sir. Question of. Yes, sir, this one.
This one? Okay,
Yes,
so
sir.
this one is basically a mixture of binomial and exponential. Okay, let's see. The length, okay, one person is exponentially distributed with expected time of 2 minutes, right? It will be served in more than 8 minutes. Okay, let's see. Can you tell me your values?
What, sir?
The values in your question.
Same, sir. Same value.
Same. Okay. So expected. So x follows exponential, right? Expectation time is given to be 2 minutes, right?
Yes, sir.
It means 1 by lambda equals 2. So lambda is nothing but 1 by 2, right? Okay. I need to find the probability at least 2 of them will be served in more than 8 minutes. Okay.
Yes, sir.
So probability that anyone will be served in more than 8 minutes is, I can write it like that. Right?
Yes, sir.
Minus lambda and then x, right? Right? So probability that it will take more than 8 minutes to serve is e raised to the power minus 4. So I can say that this is my probability of success. My probability of failure will be 1 minus e raised to the power minus 4. It served in less than 8 minutes, right? In total, I am serving 5 customers. Let's say Y be the number of customers served in more than 8 minutes. So Y follows binomial with number of customers n being 5 and probability of success is, right? And you need to find a probability Y greater than or equal to 2, right?
Yes, sir.
You can write it like that. And you can simply plug in 5. For binomial, taking the value 0, it's nothing but 5c0, p raised to the power 0, 1 minus p raised to the power 5. Similarly, this, right? It's a mixture of the probability of success you are getting using exponential, and then you have to use the binomial to find the at least two.
Yes.
It is given that assume that each person is solved independently, so that makes the condition of binomial satisfied, right? Is it clear?
Yes, sir.
Anyone, anything else? I think we can close for today.
Sir, quiz 2, there is a question of something like rectangular area. There I got the correct answer, but I am not sure whether my approach is correct or not. Just you tell me what is the correct approach? Yeah.
Okay. Okay, so sum of length and breadth is 12, right?
Yes, sir.
Okay. Find the area of rectangle is not less than 3/4 times the greatest area possible.
Yes, sir.
So first I need to find the greatest area.
Yeah, 36, sir.
Yeah, it is 36. Right. So 3/4 times the greatest area would be 27.
27. Yeah.
Right. So I need the probability that area of rectangle is not less than. Okay, it means it should be greater than 27, right?
7, yes.
That I can write B as 12 minus L. Right? Should be greater than 27. And then you have to solve this quadratic equation. So it becomes L square minus 12L plus 27 less than 0, right?
Yes, sir.
So I think it would be probability L minus 3, L minus 9 less than 0, right?
Okay.
So if you look at the number line, the possibility values L can take is in between 0 and 12. And its roots are 3 and 9. It means if L equals 3, it will take value 0. If L equals to 9, it will take value 0, right?
Yes, sir.
If it takes value less than 3, let's suppose it takes value 2. So 2 minus 3 is negative.
Yes, sir.
2 minus 9 is negative. Negative times negative is positive. So this condition is not satisfied.
Yeah.
It means it would be positive in this area. Right?
Yes, sir.
Let's see if I take any value in between 3 and 9. Let's see 5. Okay. So 5 minus 3 is positive.
Yes, sir.
And 5 minus 9 is negative. So positive times negative, it is negative.
Negative, yeah.
My condition is satisfied. So in this area, it would be negative, right? This condition would be satisfied.
Yes, sir.
If L is greater than 9, let's say L equals 10.
Again, it doesn't.
Positive, positive. Yeah, don't satisfied. It would be something like this, right?
Yes.
So you see, out of all the complete area, with 0 to 12, only in half of the area my condition is satisfied.
Yes, sir. And that is, yeah.
Yeah.
Mhm.
That's one right.
Yes, sir. Thank you, sir.
Anyone, anything else? Okay. Thank you, everyone.
Thank you, sir.
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 Thank you, sir.